Developmental networks can help us understand how the presence of specific genes can affect the phenotype of organisms. Certain genes can create proteins that repress or activate other genes. By removing specific genes, you can see how the network is affected and determine the normal function of that gene. To demonstrate this concept of developmental networks, we will be looking at characters from the office. In the office developmental network, transcription of the PAM gene is influenced by a few different proteins. If the PAM gene is transcribed, then GEM and PAM end up together. If the PAM gene is not transcribed, then GEM and PAM do not end up together. The ROY gene product inhibits transcription of the PAM gene. The Michael gene product activates transcription of GEM, and GEM inhibits the action of ROY. So, in the normal developmental network, Michael activates GEM, GEM represses ROY, which means that ROY cannot block transcription of PAM. PAM is transcribed and activates the GEM and PAM gene. GEM and PAM end up together. The expression or lack of expression of certain genes in the pathway can cause phenotypic changes. In a single mutant where the Michael gene is removed, then the GEM gene would not be activated. Therefore, GEM could not repress ROY, and ROY would inhibit transcription of PAM. The PAM gene would not be able to activate the GEM and PAM gene, so PAM and GEM do not end up together. If ROY is removed, then GEM and PAM end up together. ROY could not repress transcription of PAM, so PAM could activate the GEM and PAM gene. In a double mutant where Michael and GEM are both removed, then Michael could not activate GEM, and GEM could not repress ROY. ROY would repress PAM. PAM could no longer activate the GEM and PAM gene, so they would not end up together. If both Michael and ROY are removed, then Michael could not activate GEM to repress ROY, but ROY would not be able to repress PAM, so the PAM gene would still be transcribed and GEM and PAM would end up together.